This is an introduction to a series of 7 presentations found on HYSPLIT.com. All of them will focus on configuring an atmospheric dispersion model, HYSPLIT, to compute dose from the release of radionuclides to the atmosphere. 6 of the presentations will use the accident at the Fukushima Nuclear Power Plant in March of 2011 as a basis for the example calculations. The last example will describe configuring the model for an atmospheric nuclear test. It is assumed you have some experience using the HYSPLIT model, and therefore you have already installed HYSPLIT to your computer, and you are sufficiently familiar with how to apply the model for the most basic simulations as reviewed in the basic tutorial. The presentations are an updated version of the original extended tutorial, but using the more recent HYSPLIT version 5.2.0. However, similar results should be obtained from older or newer versions. In this updated tutorial, there have been corrections to the scripts and expanded discussions of the parameter settings of the post-processing programs, that is, the programs that are needed after HYSPLIT completes to compute the radiological dose. Most of the presentations will be just a line-by-line review of the scripts that are provided for each section, for either a Unix or Windows operating system. The scripts and required files for each example should be downloaded to a temporary or working directory on your computer and run through a terminal window. Although the tutorial sections can be accessed in any order, it is better to follow them sequentially because certain concepts are only discussed when they first appear. The presentations increase in complexity, starting with the first, a simple case of a single long half-life radionuclide with a time-varying emission rate, as read from a supplemental input file during the HYSPLIT simulation. For the second case, we create a transfer coefficient matrix for a single radionuclide species using a unit source for multiple release times, all within a single HYSPLIT simulation. The time-varying emission data are applied in a post-processing step to compute concentration and dose. In the third case, to handle multiple radionuclide species, a multi-file transfer coefficient matrix is required, with one unit source HYSPLIT simulation for each release time, which can then be converted to dose for any one radionuclide. The fourth simulation is an extension of the previous one in that it demonstrates how to update a multi-file transfer coefficient matrix as new meteorological data or revised source information become available. In all the previous cases, even when multiple radionuclides could be selected, the dose was only computed for one species. In the fifth example, dose is computed as the sum of the dose from multiple radionuclides, but for simplicity, using a constant emission rate. The sixth simulation is the most realistic and complex, showing the computation of a dose for multiple radionuclides and using a time-varying emission rate. The seventh and final simulation shows how to configure HYSPLIT to compute dose from the 213 radionuclide fission products produced by a nuclear detonation. The details from the Smoky nuclear test of August 31, 1957 will be used for the example. This concludes the introduction, and I suggest you start with the first example of time-varying emissions and dose.